good morning on Roida and my fellow friends. My name is Adif Anaraki Vijay Kumar. My matrix number is 01DTK25F1061. Today I'm going to talk about my experiment of bipolar junction transistor of my subject DEE 20143 semiconductor devices. This is from chapter 3 transistor practical work 3. The main objective of this experiment are to identify the terminals of bipolar junction transistor BJT, to differentiate between NPN and PNP transistor, and to explain the basic operation of BJT, and finally to describe the flow of current in a BJT circuit. What is a bipolar junction? It is made of three layers of semiconductor material. It has two junctions. It uses both electrons and holes to carry current. The first one is emitter, sends charge carries. The second one is base, controls the current. And the final one is collector, which collects the carriers. Let's talk about base. The characteristics are the middle layer of the transistor, very thin and lightly doped, act as the control terminal. What does it do? Controls the flow of current from emitter to collector. A small current entering the base allows a large current to flow. Works like a gate or valve controlling the transistor. Now let's talk about the emitter. The characteristics are the terminal that releases charges carriers, heavily doped to provide a large number of carriers connected to the start of current flow. What it does? Send carriers into the base, supplies the main current in the transistor, works together with the base to control flow to the collector. Now let's talk about the collector. Collector characteristics are moderately doped, less than the emitter, largest region in the transistor, collects charge carriers from the base, and reverse bias with the base in normal operation. What does it do? Collect charge carriers from the base, acts as the output terminal of the transistor, and also allow large current to flow, controlled by the base. Let's talk about the two types of transistors, NPN and also PNP. The NPN, in NPN transistor, electrons are the major carriers. The current flows to a collector to emitter, while the PNP transistor, holes are the major carriers. The current flows to emitter to collector. Now, before we start the experiment, we need to do some adjustment on our multimeter. We need to put the black color probe on a red slot and a red color probe on a black slot. This will turn the multimeter into a supply. Now, this is the taper we're going to use. To find the base, if a low resistor value, terminal is the base. If the resistor value is higher or infinity, that means it is not the base. We are going to use two transistors, which is transistor 2N222 and also transistor BD140. We are measuring 2N222. As you can see, red at the first terminal and black at second terminal. As you can see, we got no value. Sorry. We got no value. We got no value when we change. Now we change the black to third terminal and still don't get value. The third terminal and still don't got value. But if we change the red probe to second terminal and black probe to first terminal, we got a value which is the 60 ohm. Then we change the black terminal to third terminal, black probe to third terminal, we got also the same value. Then we put the black probe at the first terminal and red probe at third terminal, we don't get the value. Now we put the black at the second terminal, we still don't get the value. Okay, how to identify PNP or NPN transistor? We can identify by putting our positive side on the base and put the negative side on the first or and third terminal. That is PNP terminal, a transistor. Sorry. If you put negative side on the base and put the positive on first or third terminal and third terminal, we get value. It means it is an NPN transistor. We are going to use 2N22 transistor. I'm going to put the positive side on the red probe on the base and negative on the first terminal. As you can see, we got 60 ohms. Now we switch the black terminal to third terminal. The black probe to third terminal. Sorry. Negative to third terminal. We got a 60 ohms value. Sorry. You can see negative on the 60 ohms. Now we put the negative on the second terminal and red at the first terminal. We got a no value. And the first time, red probe changed to third terminal, we got no value as well. This shows that they are current flowing and the transistor is NPN transistor. Now let's move on. Now we are doing BD140 transistor. We put the base as is at the third terminal. Now we put the red probe at the base and black probe, which is the negative, at the first terminal. So you can see there is no value. Now we switch negative to second terminal. It still doesn't get value. But if we put the negative terminal, negative probe at the base and put the red probe at the first terminal, we got a 60 ohms. And switch the red probe at the second terminal, we got a 60 ohms as well. This shows that this BD140 transistor is a PNP transistor. Now let's move on to the conclusion. These are the conclusion. It's a bit long. I won't read everything, but I will try. BGT is a 3-layer semiconductor devices. It is used to amplification and switch in electrical circuit. It has 3 terminals, which is emitter, base, and collector. The function of each terminal, which is emitter, supplies charge or charge carriers, regulates or control the flow of current, which is the base, and the collector receives the charge carriers. There are 2 types of BJTs, which are NPN and PNP. The difference between NPN and PNP, NPN uses electron as major carriers and PNP uses hole as a main carriers. BJT operates in three regions: cutoff of state, active application region, saturation on state. And the common material used is silicon germanium. Silicon is preferred due to better stability and performance. Thank you.